Hey, hello, welcome back to our channel. Today we are going to discuss about previous MSET problems only. The chapter name is what? Electrostatic potential and capacitance. Look here, this is the first problem. What they have given one circuit diagram. Find the equivalent capacitance between A and B. Clearly they have given this is the 2C and 2C. And first of all, look here, across this A we should consider one battery connection. A is giving to the positive of the battery, B is giving to the negative of the battery. Like that we should consider. Then here current is dividing into, look here, how many parts? 1, 2, 3. If the division of the current means this one and this one, all three are in parallel condition. But how to find out the equivalent capacitance A and B? We are looking here. Look at this notebook side. See, clearly these two are in series. Series and identical means what is equivalent capacitance? C by 2. But instead of C here, 2C by capacitance is the 2C. How many are there? 2C is 2. This one cancel. But these two are in what? Parallel. So C plus C, how much? 2C. Now once again we should draw this one. Easily you can understand. This is the C and this is the C. This is across A and B. But look here, this is how much? See, 2C and 2C both are in series combination. So equivalent capacitance, same thing, 2C by 2, we are getting the C. Now you look here, these three are clearly in parallel. So what is the equivalent capacitance? C equivalent equals to C plus C plus C is the 3C. Like that easily we can able to find out the equivalent capacitance. Then we are going to the other problem. In this, what they have given, look. The electrostatic potential inside the charged sphere is how much? Phi equals to A R square plus B. A and B are the constants here and R is the distance from the center. Then the charge density inside the ball, we should find out the charge density inside the ball. So clearly they have given here electric potential. From that we can find out the charge density. Look, phi equals to what they have given, second one. Here phi is nothing but electric potential only. For our convenience we are taking that is what? That is the, we are taking V only. Then easily we can able to solve that one. V equals to phi equals to A R square plus B. But what is the relation between intensity and potential? We know that E equals to minus dV by dr. Clearly they are giving spherical body means intensity. What is the formula? 1 by 4 pi epsilon naught Q by R square. This side minus d by dr of potential is how much? A R square plus B. A R square plus B. Okay, but here 1 by 4 pi epsilon naught. Instead of Q, what is the formula? Volume charge density. Eta equals to charge by volume. This is sphere means 4/3 pi r cube we are taking. So from this we have to find out eta only here. Instead of Q, what we are writing? Eta into 4/3 pi r cube divided by r square. Then RHS side you look here, minus differentiation of A into R square. A is the constant, differentiation of R square is the 2R. Differentiation of constant is 0. You can take it this one. But we should find out the eta. Here R square and this cube is cancelled. What we should find out? Eta we have to find out. So here 4 pi cancelled. 4 pi cancelled. So this side eta by 3. Eta by 3 equals to, one more r is here, minus 2ar. After simplification, r cancel, you are getting how much? This is one more epsilon naught also here. This is the epsilon naught. Minus 6a epsilon naught. while looking this problem, no, it's looking like very difficult, but you must remember this formula: E equals to minus dV by dr. They are giving spherical body, three-dimensional body means, anyway first we can take basic formula for intensity, that is 1 by 4 pi epsilon naught q by r square. After differentiating, and instead of q we are writing eta into 4/3 pi r cube. Here we should find out the eta value. Then our third question is, look here, like see this, what they have given. Third question: assume each oil drop consists of capacitance how much C. Then we are combining n drops to form a bigger drop. Then the capacitance of the bigger drop is, see, it's very simple formula. Look here, suppose first we remember this basic here. N number of identical drops are there like this. Each drop is having how much? The radius is r and this is the n. And these are combined, it forms a big drop. That radius we should consider r. So in this, which is constant? Density is constant. Here what is the density? Spherical shape means n into each drop density is how much? 4/3 pi into small r cube. Here only one drop means 4/3 pi into r cube. So when you are using this formula only, 4/3 pi cancel. So n into r cube is equals to how much? R cube. From this capital R is how much? Both the sides we are taking cube root, n by 3 into r. So this is the relation between big drop radius and small drop radius. N is the number of identical drops. But you know that capacitance, what is the formula? C equals to 4 pi epsilon naught into r. This is one small drop. Then what happens? N number of drops are combined and it gives the big drop, means C dash equals to what we are taking? 4 pi epsilon naught into r. Okay, but instead of capital R, what we are writing? 4 pi epsilon naught n to the power of 1 by 3 into r. But instead of 4 pi epsilon naught and r, what we are taking? Initial capacitance n to the power of 1 by 3 into r. So like this we can find out. Only for understanding I have given, but direct you can remember this formula also. You should by heart. C dash equals to n to the power of 1 by 3 into r. Like that we can able to find out the next question. Then come to fourth question. It is also very easy. Look here. See, an infinite non-conducting sphere has surface charge density how much? 2 into 10 to the power of minus 7 coulomb per meter square on one side. The distance between two equipotential surfaces whose potential difference by how much? 90 volts. Assume that 1 pi 4 pi epsilon naught they have given, but you see all options they have expressed in terms of pi. A, B, C, D, in all options we should express that answer in terms of pi. So first of all, the given data is what we are taking. That given data, look here. See, this is the given data. Sigma equals to 2 into 10 to the power of minus 7 coulomb meter square. We should find out the distance. Then potential is how much? 90 volts. So we know that E equals to V by R. Instead of E, surface charge density means sigma by, that to single plate, sigma by 2 epsilon naught. And this is instead of V, I have written 90 by R. Here R we should find out. 90 by sigma by 2 epsilon naught. But we should express that answer in terms of pi, no? Multiplying and dividing with 2 pi, 2 pi. Then Q naught by sigma by 4 pi epsilon naught into 2 pi. But 90 by, instead of 1 by 4 pi epsilon naught, you know that 9 into 10 to the power of 9. And this is sigma value 2 into 10 power minus 7. Don't confuse here. This is the sigma value, and 1 by 4 pi epsilon naught value 9 into 10 to the power of 9, and this is the 2 pi. After simplification we are getting answer 2.5 by pi into 10 power minus 2. But our first option they have expressed in terms of millimeters, means we can take it r equals to 25 by pi millimeters. So just you can remember E equals to V by R, but we want sigma, means instead of E we are writing sigma by 2 epsilon naught. So in electric charges and fields, last applications of gases are there, that when you are by hearting that intensity potential, these are very useful for both the chapters. Then come to our fifth question here. What they have given in this, see, a capacitor is fully charged with a battery and then disconnected. A dielectric is then inserted into the capacitor. How do charges on surface of the dielectric and outer surface of the plates of the capacitor would change respectively? It's concept question only. It will take only 1 second if you know that. First one is increases, decreases. Second one is the decreases, increases. Third one is the increases and then remains unchanged. Then remains unchanged and increases. Look here. When we are taking this problem, no, see, this is the battery we are taking. It has both positive charge and negative charge. Whenever we are placing the dielectric in between that, then what happens? Because of that induction, this side you are getting the negative charges, this side you are getting the positive charges. So when you are fully charged and placed that dielectric, means because of that induction, first it is increasing, then what happens? No change in that, then it is remains unchanged. So our third option is right. Then we can go through the sixth question we should read first. See, if the dielectric constant of a substance is how much? K equals to 4 by 3. Then the electric susceptibility psi in terms of vacuum permittivity epsilon naught is. This concept belongs to magnetism also. You remember this formula. Electric susceptibility equals to K minus 1 into epsilon naught. Here K is what? Dielectric constant. We should find out the susceptibility only. So instead of K, what we are writing? 4 by 3 minus 1 into epsilon naught. After simplification, that electric susceptibility you are getting epsilon naught by 3. So you must remember this formula for this. Then we can go through the seventh question. See, look here, seventh question. In a regular polygon of sides, how many sides are there? 10 sides are there. Each corner is a distance of how much? R from the center. Identical charges are placed at corners, 9 corners. At the center, the magnitude of electric field is how much? E, and the potential is V. We have to find out the ratio of V and E. You know that potential is a vector scalar quantity. So scalar means we can, from the principle of superposition, 9 charges are there. See, general potential formula is 1 by 4 pi epsilon naught Q by R. 1 by 4 pi epsilon naught Q by R. But 9 drops are there, means 9 times of V. So 1 by 4 pi epsilon naught Q by R into what you are taking? 9. But intensity, it forms the polygon like that. It forms the polygon like that. It forms the polygon. So here, then opposite, this is this direction, means this is this direction. These two are cancelled. Finally, we are getting only one due to one charge, 1 by 4 pi epsilon naught Q by R square. This is equation number 1 and this is equation number 2. But the question is what we should find out here? We can find out the V by E. This is the V here. So 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught cancel, Q by R is cancel, and here R square is there. When it will reverse, our answer is how much? 9 into R. Our answer is 9 into R. So like that we can able to find out the ratio of the potential in this one. Then we are going to discuss about next question. Look here. See, this is also very easy. Already we have done the same model. A spherical drop of liquid carrying how much charge Q has a potential is how much V naught. So for single drop they have given charge Q and potential is V naught at its surface. If two drops of same charge and radius combine to form a single spherical drop, then the potential of the surface of new drop is, just now we discussed that capacitance, and drops are combined and it gives how much capacitance, n to the power of 1 by 3 into C. But here in the case of potential, you know that V equals to 1 by 4 pi epsilon naught Q by R. So potential is directly proportional to Q and inversely proportional to R. Whenever n small drops are combined, then what happens? Charge becomes 2, Q dash equals to n into Q. Then potential we are taking V dash equals to potential, already you know that, but R you know that capital R equals to n to the power of 1 by 3 into R, like this. Then we can go through the general formula for potential. Now V dash is directly proportional to, instead of Q, n times of that charge divided by, instead of R, n to the power of 1 by 3 into R. So here Q and R are constant. When it goes up, what happens? V is directly proportional to L to the power of 1 minus 1 by 3 is how much? 2 by 3 into R. 2 by 3 into R. So this is the relation. Now come to our question. Clearly they have given two drops are combined, means instead of n what we are taking 2. So 2 to the power of 2 by 3 means 2 square. Our answer is 4 by 3 times of that initial potential. So otherwise directly you should remember that here V dash equals to n to the power of 2 by 3 into V naught. No need of doing entire thing. Instead of n, what we are taking? 2 drops, 2 to the power of 2 by 3 into V naught. But our answer is they have given 4. So 2 square is how much? 4 to the power of 1 by 3 into V naught. So like that we can able to do problems from the electric potential and capacitance. Thank you everyone. Please subscribe my channel.